Hello guys, welcome back to my channel GravityTech. This is the next video on C programming series. In last video we covered pointers in detail, and in this video we'll be covering functions in detail. And then there will be like 4 or 5 more topics will be remaining in this series, and that will basically conclude the complete C programming course, right? Yeah. So this series will basically help you to learn complete C programming from the scratch with the proper examples and in very simple and easy language. So even if you don't have any programming background, you should be able to learn C language with the help of this complete series of videos. Okay. So guys, if you want to, I would say if you haven't watched the earlier videos, I strongly recommend you to go to those videos to learn what are the topics we have covered until now. Okay, now what is the agenda of today's video? In today's video we'll be covering functions and the things which we'll be covering as a part of next topics. Now what are the functions? Functions are basically a block of code. Functions are basically a block of code that perform a specific task. So it takes some inputs. It can take like 0 inputs, it can so no inputs at all, or maybe more than one input. It may not return anything, or it may return something, right? So the function is always written like this. Okay, so function will be always written in the curly braces, so in this way, and then it will have some name. The function will have some name, right? It will accept some inputs. It will accept some inputs. Okay, and it will return some output. Okay, this is how the function looks like. So you may have seen it, right? Main is a function. Main is a function which returns integer, right? Main is a function which basically returns integer, and then its name is main. It accepts nothing because there is nothing inside. Then whatever we do a coding, that basically goes inside main, and then we write here as a return 0, right? Return 0. What does that mean? This main function is basically returns 0, right, when it is successful. So in this case you would basically say this is your main function, right? The name of the function. It takes input nothing, no inputs, right? No input, and then it basically returns 0 if success and non-zero if it is failure. Okay, so this is how it is. We'll see the things practically and what are the functions are. Right, now let's see what exactly are we going to cover as a part of the practical exercise on the functions. We'll see what are the functions, how to declare the function, how to define a function, and how to invoke the function. How to invoke a function with value, how to invoke a function with reference address, and then how actually to deal with the recursion in C. Okay, now let's go to the IDE for the example. Yes, so as I mentioned, it is a block of code, right? If you look at the main is a function. Okay, main is a function. This is the name of the function, and whatever inputs the function takes, the inputs are basically always enclosed into the open braces, right? And then it returns integer. Whatever is it is going to return that data type, we need to put it here. Okay, and then here whatever the body of that function, right? Body of function to be written, and then at the end output to be returned with the help of the return statement. Remember, return is the statement which is used to return the output from the function. Okay, so as I said, main is a function, right? So from this, what you can basically conclude how function looks like. There will be a function name, because whatever function, right, it should be it should have some name, it should have some inputs here, correct, one or more inputs. If no inputs, right, then there will be nothing inside. If there is one input, then there will be input 1, right. If there are 2 inputs, it will say input 2. There are 3 inputs, it will say input 3, and so on, right. So the number of inputs we can provide. Then you need to basically have all the body of that function, right. Then it should also have some return type, what exactly this function is going to return, right. Is it going to return integer, float, character, and right, pointer, that means. And then whatever the return type variable, right, return type variable should be written here. Now let's try to maybe define one simple program. Okay, now the simple program what I want to write is addition of 2 numbers. So what exactly basically I want to do, write a function which takes input as 2 numbers and returns addition. We also call it as a sum, right, of those 2 numbers. So it's easy, right? What exactly we want? Let's say if I write some function and if I pass 2 and 3 to that function, what it should basically produce 5, correct. Instead of 2 and 3, if I pass minus 3 and 5, what it should basically produce? It should basically produce 2. Why? Because minus 3 plus 5 is 2, correct. 2 plus 3 is 5. Now let's try to define the function. Now when we want to define a function, right, we need to write a function name. So let's say addition is the function name, right. Now inside, see, so whenever we define a function, right, we basically take care of 4 different things. Function name is the first thing, then input parameters, that is also called as arguments, okay. Then we think of a body of the function, and then return type and returning the value, right. These are the 5 things we basically deal with. Now let's try to maybe define a function that way. Okay, what I will do, I'll basically just remove this part because this is not going to be a part of program. So very first thing, function name, what it is going to take. Let's say function name is addition. What are the input parameters? It will take 2 numbers as input parameters, right. How many numbers? 2 numbers. Now decide which numbers are going to be that. Are those going to be float? Are those going to be integers? Are those going to be something else, right? For now, let's take both are the integers, right? 2 integers. So it will be like int x and int y, correct? Then body of the function, what it basically should do, right? It needs to add both of the numbers. So it needs some other variable z, which should basically have z is equal to x plus y. Now return type, it is going to return a sum, addition of these 2 numbers, correct. So what it will basically return, x plus y, and then it will return z, correct. So it will basically return it will add integer and integer, it will return integer. So return type should be what? Int. And what will be the value it will be returning? It will basically return z, correct. Now this is how you should basically just start thinking. Now let's try writing it one by one things, right. Very first thing, function name is what? Addition, right. It's going to take 2 numbers as the input. So you really cannot give the numbers in definition as is, right. You need to basically provide the data types as well, int x and int y. Okay, that's done. then we need a body of function. Body of the function is always written into the curly braces, right? What exactly it is going to do? Addition. So let's have another variable which will basically hold the addition of these two numbers, correct? Then what is the return type of this? Now these two integers will be added. The final answer will be integer. So it will basically return the integer. So return type here we should basically mention is what? Int, correct? And then it should basically return the value as well from the body of the function. At the end it should return the value. So what it is going to return? It is going to return z. So whenever we will have the value of x is equal to 2 and y is equal to 3, at that time what will happen? The z will become x plus 5, that is 2 plus 3, 5, and then it will return 5. So this function will return 5 if these two input parameters are given. This function will return 2 if the input parameters are given this. Okay, that way. So it's easy. Now this is what we call it as a function definition. Now how to invoke a function, right? See. Now just let's try to invoke a function. So int x and y, right? Now what we want is sum of these two, correct? Now we will ask user to enter the numbers. Enter two numbers to be added, correct? Let's now try to enter the numbers. So we will basically use scanf for that, %d, because we have two numbers x and y. Will that work? No. Why? Because in scanf we need address of the variable, not the actual variable. So this should be what? X and y, right? Let me just put up slightly. Now user has given the input, right? But what we need to basically do, right? We need to find out the sum of those. Now to find out the sum, we have a function. So we need to basically, this is called as a, see, this is the definition of the, this is the definition of that. This is basically definition of function, and this is where you will invoke. How to invoke a function? When you invoke the function, you don't need to write the return type. Remember, this is a invocation, or we also call it as a calling of a function. This does not require no return type needed, right? Because, and then only variables with comma separated are required to pass as input. No need of data type. Now, so you will just say name and then the values x and y. Okay. And then if you just print f, sum is equal to %d and sum, it will basically print the sum. Now let's try to execute it. Before execution, maybe I will tell you what will happen. So as we know, the program will always start, when you execute the program, it will always start with the main. It will come here, it will execute line number 48 xy. So in somewhere in a memory, it will basically store or allocate some space for x and y. So this is your main. Okay, let's say this is your main function. Which function? Main. So if this is your main function, so in this main function, now you will have one block for x, one block for y, and one block for sum. Right? Let's say when you say like this, you will be asked to enter two numbers. So let's say you enter numbers 2 and 3. So what will happen when you write this line? This means you are calling or invoking the addition function with inputs as x and y, and there is another box of function in a memory whose name is addition. Okay, so when you call this, right, basically from this side it basically calls this. Then here there are other copies of variables there are other copies of variables, remember. So x and y. What is x? That is 2, that is 3, and then there is a z which basically has 5, right? And then this is where it will say x plus y is equal to 5, and then when we say return z, it returns 5 from this place to the place where it was invoked, and then this function is completed. The 5 comes and that 5 is replaced with this part. So the answer will be what? Sum is equal to 5. So 5 goes here. Okay, so that's how the function basically works. Now what happened here? Okay, it will come, this is the first line executed, this is the second line executed, this is the third line executed, this is the fourth line executed, these are comments, so ignored. This is the fifth line executed, but the fifth line execution says invoke the addition function. So what it basically goes, it goes here and it runs this function, the complete block. Then from here it returns the same thing to the place from where it was invoked, and then that z basically is assigned to sum, then some values of 5. Remember, this x and y and this x and y are different. The way we can have more than 2 people of the same name in the same society or same village, right, or same area, similarly in this case the other value names x, y are same, they are different. See, this x might have, this will have different address and this will have this different address. This will have different address, this will have different address. We'll basically try to see how it is. Let's first try to run it, right? When we execute this program, okay, let me first save this. So when we execute this program, it says some error. It says addition is not declared in this scope. What is the issue? The spelling of addition is incorrect. We forgot I here. Okay, so that's why it was failing. Now when we execute it, right, it will say like this: enter the two numbers. So let's say we enter 2 and 3. See, it returned sum is equal to what? 5. It basically from this place it went all to this place. This value of x is copied to this x. This value of y is copied to this y. Okay. Now just to show you the address of this x and y are different here, let's try to print the addresses. Okay, address of x and y are %u, %u. Let's say, right. So address of x, address of y, and this is a addition function, correct? This is just to let you know that addresses are different. So we are printing address here once, and then we will print the address here once. Okay, not in addition, but this will be main function. So when we now run this, it will again ask for the two numbers, let's say 2 and 5. So the addition will be what? 7. See, so in a main function the address of x is what? 6487576, but in addition function address of x is what? 6487536. Here it is 76. Similarly, main function the address of y is 6487572, and here 6487544. So remember, even if you see the same names here and here, right, these are two separate entities. So you can simply have, instead of x, you can have a, you can have a b, and then you can have here a, right, and here b. So it really doesn't matter that what are the variable names you are putting into the definition of the function. What ultimately it is going to do, right? It will basically, when you are saying this addition xy, it will run, it will invoke this part, but the value of y, x will be copied to the a, y will be copied to the b. So now a and b are the separate copies. So even if you make any changes into this a and b, those will not reflect here. Okay, remember. So you can have any names of the variables inside a function. Now let's try to execute it if we change it to ab, what it will be. Exactly. Now what it is giving, we are trying to use x and y, but is x and y defined in this function? No. So the compiler doesn't know what is x and y, because x and y is not part of this. This is not in a scope. So this should basically be removed. Correct. We also don't want this because we don't want to print a address maybe, right? So when you invoke it, it will now, let's say, minus 3 and 5. The answer should be what? 2. See, the sum is 2. So what is concluded? Function can have the variable names anything. It is not supposed to be matching with the variable names which you are invoking. This is called as a pass by value. So not x is passing. The value of x is passing actually, which is being copied to a. Not y is passing. The value of y is passing and being copied to the variable b. And then a and b are used only in this function. A and b are not known to this. Main doesn't know what is a and b, what is z. Similarly, x and y. This addition function doesn't know what is x and y. So what does that mean? That means the function is not known to the compiler. So what happens, right? See, whenever you invoke anything from this, right, it will try. So how compiler works? Compiler will start from the line number 1. Okay. Compiler will start from the line number 1. It will go on line by line by line by line by line. Okay. It will search for everything, whether the compiler knows or not. Now in this case it will come here, because main is the standard function which is supposed to be part of every C program. That's why it will say yes to this. Now main starts here, then it will come here, int x, y, okay. So what compiler will do, it will basically store 4 bytes memory for x and y. Then it will come to this line, it will say sum. It will store 4 bytes memory for sum as well. Now where it will come? It will come to printf. So it will call this printf as a function. See, this is also a function. Printf is a function. Okay. And what it takes, this is the input it is taking. This is the input it is taking. Okay. So here we are invoking, we are calling the printf function. What we are doing, we are calling or invoking printf. And then it is basically going somewhere, there is where printf is defined, and then it is processing all that stuff. It will print this part. Then here we are calling the scanf function. See, scanf functions takes this many inputs. So here we are basically calling or invoking what? We are calling or invoking scanf. Okay, that's how it is. Now, then you will say where the compiler is getting scanf and printf from. See, do you see this line? Hash include stdio.h. In this file, scanf and printf, both functions are declared. Okay, and then there is some library where those are defined. But compiler needs a declaration. Compiler doesn't need the definition. Even if you say, even if you declare it, right, it's like that. So that's fine too. Okay. So now in this case, what the compiler will look like, where it comes to here, it will say, hey, addition is I know what is sum. Compiler will say I know what is sum, what is equal to, but I don't know what is addition. What are you trying to say as addition, right? So we need to basically declare that here. Here we need to tell the compiler how the addition function is. So this is called as a declaration of a function. Okay. Now how do we call it as a, how do we declare it? What it returns, what is the name, and what kind of inputs it actually accepts. This is called as a declaration. So in this case, compiler will say, okay, I know now addition is what? Is a function which is going to take two integers as the input and it will return integer as output. Then it will try to match that here. Okay, addition, yes. It is going to take two integers, yes. And then it will return some integer which is going to store into the integer, yes. So now this matches with the declaration what we have given. So the compiler knows. Now it will run. Okay. Now when you run it, see, it basically ran, and now if you enter -9 and 3, it will basically just give you -6. Now just notice the error. Okay, I'll tell you, I'll show the error. If I don't declare it here, what will be the error? It says error, addition was not in the scope, right? Because addition doesn't know. A compiler doesn't know the addition. But what if, now see, do you see it here? Here it says compiler log, right? The error is what? Of compiler. But now let's say I declare the function, but I don't define it. I'm just commenting out the defining part. What does that mean? Compiler will now know. Compiler will know that yes, there is something addition, that's fine. So compiler will pass on this. Right? Now see what it says. In this case now .exe is failing. Undefined reference to addition intent. So what does that mean? The compiler phase is passed. This is a linker error. What does it do? It is basically the linker error. Compiler knew addition is the function of this kind and this is how it looks like. But compiler really doesn't care about what does it do. All the compiler wants is how does it look like. If that matches with how it is being invoked, it is okay. Then at the end, when before execution linker comes in a picture, at the end before execution linker comes in a picture, correct, like this. So if you write your a.c, correct, let's see, if you write a.c, right, it first goes to compiler, correct, then it goes to linker, okay, and then it executes. Right. Now the declaration error was in this phase, but when we declare and don't define, this will be, error will be here, and when we declare and define both, then the error will be, there will not be any error, it will execute successfully. Remember. Now in this case, let's say if we maybe just try printf now, right? I said that printf are part of hash stdio.h. Right now what I will do, I'll comment out this part. Now see, the printf and scanf will give the error. See, do you see what printf says? Printf was not declared, scanf was not declared. So there are two errors now we have, right? See, what does that mean, right? You should basically declare the function and define as well in case you are dealing with the functions, remember. So that's what it is basically when we say declaration, when we say definition, when we say invocation. Remember? Now let's see what are the function types. There are two types of functions, library functions and user defined functions. Library functions are the functions which are there into the library, right? Like we use printf, correct? But did we define the printf? We did not, right? But what if I define the function printf, let's say. If I define a function printf, right? Now char star yes, and then I will just say nothing. Let's say I just return 0, right? Now what will it work, right? And I will just maybe simply let's do like this, right? And I'm not using scanf, let's say. I don't want to use scanf, I will use printf. I don't want to use the printf from the stdio.h. So what will happen? Oh, in this case, this printf is not matching with what we have, right? And let's only use this. Why? Because this is a string, what we are passing to the printf. What it says, warning, deprecated conversion of string character to what? Char star. Okay. It is what basically it should be like this. Yes. Deprecated conversion, right? What exactly the error is? The error is something different. It says undefined reference int. Addition is not defined. Oh, we have commented out this. We did not look at the error, right? See, it executed. See, it did execute. So what exactly did it do? For this printf, it simply went into this, right? So how the things work? The function should have a declaration. The function should have a definition. The function can be a user defined function, or the function can be a library function. Library functions means the functions which already C provides and we don't write it. Now in this case, printf and scanf are the functions which C language already provides. Okay, and those are declared in this. That's why you can directly have it like that. Now there are other functions as well which you can directly write. Okay, let's try to use some of the functions, right, which we maybe use it. Let's say hash include. We have already used. We work with the strings, right? So let's say string.h. Now what all the functions string.h provides us? str cat, str cmp, str ncat, correct? str cpy, str ncpy, str len. All these functions are declared in this. So if you directly use it, you will be able to use the function. We already used this in the last videos, right? Now printf, scanf are part of this. If you use include math.h, it has a power function, it has a square root function, right, and so on. Okay, so this way there are some predefined functions of library functions. These are called the library functions which we can directly use. Now let's say we use power now. Okay, now how the power will be, correct? Let's use, so very first thing we need to include math.h. Yes, we have it. Now let's try to use power. Instead of addition, what we'll do, okay, let's have addition as well, and then maybe we'll have a power too, correct? So this will be what? Let's say power. Let's have one more variable here as a power, correct? And then we can use the function power. So what it will do? It will power x to y. So if you pass x is equal to 2, and y is equal to 4, this should basically give 2 raised to 4, that is what? 16, right? And this sum will basically give 6, 2 plus 4. Now let's try to use this. Now this should be what? Power, correct? power is equal to %d and power. When we run it, it will ask for two numbers, let's say 2 and 4. See, power is what? 16 and sum is what? 6. But did we define the power the way we have defined the addition here? Did we define the power? No. Why? Because power is already a library function that we are just supposed to use it. We really don't need to define those, correct? So remember, this is how the library functions are there. Okay. So that's how library functions are, and then these are called as user defined functions. The functions which we define, the functions which user defines are the user defined functions. Okay. Now some functions may return a value and some functions may not return a value. Okay. Now how it will be? Let's say you want to print some message, right? You want to say hello, right? So in this, so how you would say hello? You want to write a hello function. What it will do? It will accept nothing, right? And then it will say printf hello, how are you? Correct. But we don't want to return anything. So what does that mean? When we don't want to return anything from any function, we just need to say void. Right? What does it mean? Now the hello is a function which does some part and it returns nothing. If there is a return, you need to write as a return and that type of variable. Right? You really cannot return float when it is written here integer. It has to match, remember. Is it? So the functions can be of 4 types. Okay, I might have written it here. See, so a function without inputs and without outputs. That is without return value. Without inputs, that no arguments, but with valid return value. It will return something, but will not take any inputs. See, now in this case, this is basically a example of main function. Main returns integer, correct? And it takes nothing. See, without inputs. So main doesn't accept any inputs, but it returns some valid return value, that is integer. Correct? This is the main. Now in this case, let's say you just want to say if you want to print something, right? Let's say void hello. So what it will do? It will accept nothing and it will return nothing. Void is a data type. Okay, void is a data type which basically says nothing. Not any type of the variable is what we call it as a void. Now with input parameter valid arguments and without return value. What does that mean? Let's say you want to basically process 2 numbers. You don't want this addition to return anything, right? You just maybe want to print everything here only. You don't want to return a value. You will say addition is %d. So you will simply say a plus b. So are you returning anything? No. So you should basically just simply say void. What does that mean? You are accepting some values as an input, that is arguments, but returning nothing. It will just print what? Addition is equal to this. But at this time now, you should also match the return type. Now the addition is not returning anything, so you cannot really collect the value of addition, returning value into anything, right? Now it is simply what it will do, addition, nothing return, and then it will basically x will be copied to a, y will be copied to b, it will print this, and since it will print this, right, we really don't need this. Correct. Let's comment out power 2 because we are not using power as of now. So what will be the value when we print, when you run it? What it says. What is the error? Ambiguous new declaration of void. Ambiguous. What is it mean ambiguous, right? Ambiguous means confusing. They are saying old declaration is this. Here we are saying addition looks like this. it returns something and it takes something, two values. But when we are writing as a definition, we are saying addition, it takes two inputs but returns nothing. So it should basically match. That's why it's giving the error. So you should basically just say here as a void addition intent, right? You should match. Now if you run it and if you say like minus 18 and 34, it will give you the addition as a 16. Minus 18 plus 34 is 16. So that's how it is. So we saw a function which takes nothing and returns nothing. We saw a function which takes nothing but returns valid value. We saw a function which basically, this case we saw, right? This also we saw valid inputs and no output, right? That is what it was. It was void addition int A int B, correct? Now this one we already saw with valid inputs as well as valid output. That was int addition int A int B. Okay, so this is how the 4 different aspects of the function depending on what is the input and what is the output. So function can have no inputs, no output, valid input, no output, valid input, no output, right? Then no input, valid output, and both valid, right? The 4 combinations, nothing else. So some of the header files we already saw, stdio.h, where printf, scanf type functions are already there, standard input output functions, stdlib.h, where there are some library functions are there, standard library functions, math.h, where all mathematical related functions are there, sine, cos, tan, sec, cosec, those are also there, string.h, all of the functions using which we can manipulate the strings, all those functions are here. Everything related to time will be in the time.h, etc. Now let's look at what is the call by value. This we already saw it, but I'll just maybe put on some lights here, right? What exactly the call by value is. Call by value means it basically makes a copy. Okay, it basically makes a copy, right? Now let's maybe try to remove all this part. Okay, so we will have here, let's have it void only, right? We don't want the hello as well, and the definition is this. Now what exactly we will do? We want to see a call by value. Now in this case what will happen? Compiler will come, while executing it will first execute this, it will then execute this, it will try executing this, and it will come to here. Okay, and then it will execute it. Now when it comes to here, as I already mentioned, it basically creates separate memory block for both of the functions. Okay, this is your main function and this is your addition function, correct? Now here you have A and here you have a B. You can also have the same names. Okay, here you have X, correct, and here you have a Y. So what it is doing, when you say X is equal to 2 and Y is equal to 3, it will simply use the values, call by value we are saying, right? Call by value will do, it will copy this 2 to new location, copy this 3 to new location. It will not actually pass the values X and Y. Okay, it will pass the values of the location, memory location. That's why these are called as the pass by value. Now what is the benefit of this and what is a loss? Maybe what are the pros and cons, right? See, the first thing, whatever operations you do here, you change this 2 to 5, right? You change this 3 to 9, you can do it, and then it will really do not impact these values. That's the first thing. But the second thing, if you change the values here, right, that will not give the correct answers as the original values are different. So remember, call by value has an advantage in some cases and call by value has disadvantages in some cases. So let's maybe try to look at practically how does it look like. Okay, now if you look at here, so call by value, right? Let's maybe try to keep the same name so that you will know, right? We already had the same names earlier, right? X and Y. So what it is basically doing now, whatever X and Y you are passing it from here, let's say 4 and 8. So what it will basically do, it will return right here, addition is what? 4 plus 8, that is 12. So see, addition is what? 12. But if you change here, X is equal to 20 or X is equal to what? X plus 10 to 20 and Y is equal to Y plus 4. So what it will do, it is basically manipulating the value of X and Y. So when you say X, when you pass X is from 4 here, but in this statement X is becoming 24 and in this statement Y is becoming what? 8 plus 4, that is what? 12. So when it gives X plus Y, what it will give? It will return 36. It will print 36. Is that what the correct answer is? No. So that is what the drawback of maybe a pass by value. Pass by value means it creates a separate copies in every function call. It really doesn't refer to the actual values, actual variables which we are passing. Okay, remember. And then if you try to print the values of X and Y here, right, let's say now I'll try to print the values here. Print before calling addition function, right? Before calling addition function, what is the value of X and what is the value of Y? Let's see. So when we call the before calling, right? Then after calling, so the invocation has happened and here we will say inside. Inside addition function. See now what it will basically do. Yes, so when the program is executed, it will execute this. So in a memory it will create a block for main function. In that main function it will reserve 3 integers X, Y and sum. Each one will have the 4 byte size. It will print this line with the values 4 and 8, correct? Then it will go here, addition X and Y. It will come to the function definition. It will say X and Y. So this X and Y are the separate copies of the addition function which will be created in the memory. Into this X, this value of X4 will be copied. Into this Y, the value of Y will be copied as 8. So these are X and Y are the local to this function. So X will become X plus 20. So X becomes 24 because X is already 4. Y becomes Y plus 4. As Y was 8, Y will become 12 because Y is equal to 12. So, and then it will try to print inside addition function. This is second, right? This will be a first print This will be a second print, but what it will print? It will print x is equal to what? 24 and 12. So it will print 24 and 12, and this will basically print 4 and 8. Then it will print addition is this x plus y. So and then it is basically inside this, right? So this is a third thing which it will print is what? Addition is equal to 36. And then it will go back as it is ended, right? In this, from this line it will end. So it will actually come to the next line. So this is done. So this will be executed after calling the functions x and y. But since this addition function is over, whatever we did into the addition, that was local to addition, and this function has got nothing to do with it. This function has their own copies of x and y, which will refer. So it will again say 4 and 8. Remember. So what should be the answer? Before calling addition 4 8, then inside addition 24 12, then addition is 36, and then after calling addition function, that is what? Again 4 and 8. Okay. Now let's try to run it. When we run it, see, I told you guys, right? Before calling function 4 8, then it will come, as we are calling from here, it will come here. Inside 24 12, addition is 36, and again it will go back to the main function where the value of x is still 4 and y is equal to 8. So it will have that 4 and y is equal to. This is what we call it as a call by value. That means the arguments what we are passing is what? Call by value. Now what is mean by call by reference? Call by reference or call by address. So what we will basically pass now, instead of passing actual values, we will pass the addresses. What we will pass? Address. Let's say we will pass address of one variable, and we will pass one as a simple variable, right? Now when you pass address of x, will this work? Let's try to execute it. Hey, it gives the error. What does it say? It says invalid conversion from int star to int. So whenever we store address of variable, so what is going to happen? It will try to store this value, that is address of x, into this x. But to store the address of any variable, we need a pointer variable, correct? And since you want to store this, so you would basically need it int star x, correct? So int star x. Now will this run? No. Why? Because when we declared it, inside the declaration we need to also tell them that one is the pointer address and one is what? A normal variable. Now will that work? Still, hey, it did work. But what is happening? See, it did work, right? See, it is saying 4 and 8 correct. Then it is basically going inside the function. The value of x is equal to what? 6 4 8 7 6 5 6. What is happening? It is star x. So the value of x is what? The address of this x. Correct? So this is different. Okay. So if we want to actually have the value, what is basically happening here, I'll tell you. Okay. So this is your main function. This is your main function. And here you have the x. Correct. Now this is your addition function. Here there is a addition function. This is your addition function. And then here also you have the x. These both x are different. Okay. But this is a pointer. This is x is a pointer and this is a normal variable. Correct. So from here passing the address. So whatever the address, let's say FFFF, right? That address will be stored in this. And this x will have some other address, let's say, right? Now, what we are trying to do, x is equal to x plus 20. So whatever address you have stored inside this, you are basically doing plus 20 there. Correct? But we should not be case where you should be adding here. So if you do star x, it will basically refer to the value at this address. Right? So that's the benefit. Now this will directly be changed. Now how it will be, right? So this is star x. So if you want to access the actual value at the location, you just say star x. Now to also print the value, you should basically have the star x. You should have star x because we are passing as the address of x. So it should be captured into pointer variable, and then in the complete block of code, that is function, we need to use with star. If you are passing the address, you need to catch that into the pointer, and then at the every transaction, whatever statement instruction you are working on, it should basically have the star reference to it. Now this will basically work correctly. See, they say very first is before calling is 4 and 8 here, 4 and 8, correct? Then into the addition, star x is equal to star x plus 20. So what it will do, it will go to the location which is into the x, and then it will change that value 24. So actual value of x is now changed 24. So x is equal to 24, y is equal to 12. Addition is what? 36. See, after calling, now it has come here. It says x is equal to 24. Changed? Yes. So what exactly does that mean? If you want actual values rather than values, right, to pass the reference or address, so that these, even if you make any changes here, those will be reflected here. You just need to what do? You need to pass it as a address. Correct? So when you pass both as an address, it will be what? Address of y, star y. And if you want to do star y, it will be what? Star y here, and you can just use star y at the all. Now how it will be executed in this case, right? So it will come here, and then it will print both of these. So it will basically have the memory allocated for these three variables. It will come here, it will print before calling addition, x is equal to d, y is equal to d, that is 4 and 8 it will print. Then it will invoke the function from here, and then it will come to here. This is the second part. Then int star x. So it will copy the address of x into the x. So star x will be actually actual value. Int star y. Why? Because we are passing the address value. Now star x is equal to star x plus 20. What does that mean? Change the value at the address which x has in it, right? So actual value of x will be changed to 24. Similarly, actual value of y will be changed to 12. And then when it gives addition, that is what? Inside addition, it will print 24 and 12. Then here it will print addition, that is what? 36. Then once it is all done, it will go back to this. Once it comes back to this, right, it will say after calling the addition, x is equal to d, y is equal to d. Now in this case, the values are already changed. Okay, so it will be have the 24 and 12 with the changes. So when you call by value, you cannot change the actual values, but when you call by reference or call by address, you can change the actual values. When you run now this, it says, see, now here is address int star x, here is address int star y, but why it is failing? Because in a declaration we have one int star and one int, so it should basically have the int star, int star. So when you run this, it will simply give you like this. See, so earlier it was 4 and 8, the values of x and y, but at the end, after addition function is done, inside the main the values of x and y are changed. So that's how the pass by reference is. Okay, or pass by address is. Now let's look at the what is the recursion. Okay, let's look at the recursion, the last part of the function. Now what is a recursion? Recursion means what? Function calling itself. Function calling itself. Now let's do one thing. We'll maybe just remove all this part, right? So what I will do, I'll say I'll define a function print hello. Hello calling. It will print hello calling, right? But not here. Okay, now this function is something different, which returns nothing. Print hello is a function, it takes nothing, and it basically simply prints hello, printf. Now what will happen when we run it? It will print hello this once, correct? See, print hello was not declared. Again we made that mistake, we did not declare it. So we need to declare. We should say there is a function which returns nothing and takes nothing with the print hello. So this basically is a declaration. Now when we run it, see, it will say hello calling. But what if I put it like this now? Print hello. So what is happening? What is happening in this case, right? So it is basically, this is called as a recursion. See, from main we are calling, or maybe let me do it like this, right? So let's have a, yeah, see, it will come to main and it will invoke this, it will call, correct? It will call, it will come here, correct? One, then it will execute this, and then again it will call this, so it will go here, correct? Now again it will execute this, it will go here, again execute this, it will go here, again execute this, it will go here, it will go here, it will go here. So what is happening? This printf hello is calling to printf hello, correct? That means a function calling itself, a function calling itself, that is called as a recursion. Remember, a function calling itself is called as what? A recursion. Now if you try to run this, this will basically be just a infinite call. See, hello calling, it's just printing out, okay? And then if you just change the order of this, what will happen? It will never print this, it will just go in the infinite loop. It will call this, it will come here, it will again call this, come here, again call, again call, right? So it will be never ending loop with no output. See, there is no output, and then it basically executed so many times. Okay, this is what we call it as a recursion. So a function calling itself. Now what if, let's say, I want to print, okay, I want to print values of natural numbers reverse from reverse will take afterwards, let's say, right? Reverse will take afterwards, but I want to print values recursively 1, 2, 3, 4, 5, 6. these numbers I want to print using the recursion, right? So what I will do, I'll change this print hello to print number. That's it. I'll take some input as a int num. Right? It will need return nothing. So this will basically be what? Print number, but in a declaration we need to say it takes one integer, correct? Instead of this, what we want to print the number, correct? So it will print the number, and then it will call the same with num plus 1, correct? So what will happen in this case, so we will basically just call it with 1. So it will come to main, see, it will come to main, okay? So it basically creates a stack. It creates a stack like this. It creates a stack. So very first function called is what? Main. Okay. So when main is called, it goes at the end. Okay. That is in a stack. Now it calls print number. So print number will go. That is what print number is. I'm not writing complete name. Print number with input what? 1. Correct? With input 1. Now, so it will come in this, and then it will print. So it will print that number. What you have passed 1. So it will print 1. Now it will again call that function print num plus 1. That means 1 was there, right? 1 plus 1 what? 2. So now it will call print num with 2. So now the main is not yet finished. P1 is not also finished. Now it is calling P with what? 2. Correct? And so on. So now it will print 2, and then again it will be P3 will be called. Correct? That's how it will print infinite natural numbers. It will print infinite natural numbers. Why? Using recursion, because print number is a function which is calling print number only. Right? That's why it is what? Recursion. So when you try to run it, it will basically be what? Infinite natural number. See, it is printing all the natural numbers up to 1 by 1 by 1. Is it? Yeah. Now, what if you want to print it reverse? So what happens, right? Or maybe let's say if you want to stop when it is 6. Correct? So if num is equal to 7 or num is equal to 6, you simply return, right? There is nothing but we will return it. Correct? It's always good to put this inside the curly braces. For single statement, you don't need to be inside a curly braces, but it's always good practice to write it this way. So now what will happen, I'll tell you. Okay, now we'll try to iterate it. Correct. Now it will be again a stack created. How the stack will be created? Like this. First main function will be called. Okay. Then it will print 1. It will call P1. P1 function. P1 will be called. It will print 1 with this line. It will go here. It will check whether num is equal to 6. No, num is what? 1. So it will again call a print number with num plus 1, that is 2. So it will call P2. Right? It will call P2. Then again we'll go here. It will print 2. Right? On new line it will obviously print. His num is 6. No. Again it will call P3. Okay. It will call P3. Again it will print 3. Then P4. right? Then P5 and then P6. This is how it will be called. Okay, and then it will maintain the stack of the functions. It will maintain the stack of the functions. So now let's see how it does, right? So it will print 1, 2, 3, it will print 4, it will also print 5, it will also print 6. So once 6 is printed, right? Once 6 is printed, it will come here. It will check num is equal to 6. Yes, 6. So it will return. Return means do not go beyond this line, correct? So this will not be executed then. So when it says return, that means the print number function called with the number 6 is completed. So from the stack, it will remove out this. Correct. So it will remove this. It will simply remove this. Now again it will come back to the P5. Is there any other thing which is to be executed after this line in P5? No. So it will finish P5 too. Then it will finish P4. Then it will finish P3. Then it will finish P2. Then it will come to P1. And then it will come to main. And then the function will, the program will be over. So this is how it is, right? Now let's see, let's try to execute it. What does it give as the input? See, it says 1, 2, 3, 4, 5, 6, and then it just exited from. Now what if I add it here? Print %d and num. What I'm doing, I don't want to do this, maybe, right? Or maybe let's do this as well. If I execute it, what it says, print f. I did not write f. So see, for this first printf, it printed 1 to 6, and this for this printf, it printed 6 to 1, 1 to 6, and 5 to 1. Why? Why not 6? See, so what happens? It will basically go to that stack, right? The way I said. So let me just take out the pane. Yeah. So when we, let's take example of 4 values only, right? So it will basically go to here, yum. It will come here with P1. It will come with P1. It will print 1. It will print 1. It will go in this. Is num is equal to 6? No. Then it will again call the same function with 2. But see, P1 is not finished yet. P1 is not yet finished. There are some things which is yet to be done for P1. So then it will call P2. Okay. It will print it. It will check. No. It will call 3. It will go. It will print. It will call 4. It will go. It will print. It will call again 5. It will go. It will print. And it will call 6. When it calls 6, it will print 6. Right. So up till now, the 6 numbers are already printed. Right. The 6 numbers are printed now with this line, because this line is executed. But this line was after the function call, recursive function call. So these are supposed to be executed at the end. So when it says return, it will go to the stack and see what was the latest, print 6. Okay. So it is not, it will not come out. Now next it will take out print number function with the 5. So num value is 5. So it will print 5. Then it will take out 4. So print number 4, print number 3, print number 2, print number 1. This is how the recursion works, remember. Okay. So when you try to run it, now it will basically just print it like this. So if you want to print the numbers in a reverse, and let's say if you want to print the 100 numbers in a reverse, you can simply just go on like this, starting with 1 and putting numbers in the reverse. See, so it says up to 1 from the 100. Okay, so this is how the recursion works. Now let's try to find out, let's take one example of the recursion at the end of the function. Let's try to find out the factorial of a function, factorial of a number. Now we find out the factorial of what? Natural number. We find out the factorial of what? Natural number. Now what is a factorial? You should basically know the concept first. Correct. Let me remove this part so that it will not be a confusion anymore. Now, what is the factorial of a number? If I say 3 factorial, what it should basically give? 1 into 2 into 3, that is what? 6. If I say 4 factorial, so it will be a 1 into 2 into 3 into 4, that is what? 24, right? Then so if I say 8 factorial means the multiplication of 1 to 8 numbers. That's what the factorial works. Now we want to find out the factorial. Now see, you should basically remember factorials, common factorials, right? So factorial of 0 is 1, remember. Factorial of 1 is also 1. Okay, and then 2 onwards this logic starts, right? If it is 2 factorial, 1 into 2. If it is 3 factorial, 1 into 2 into 3. 4 factorial, 1 into 2 into 3 into 4, and so on. If it is a 50 factorial, 1 into 2 into 3 into 4 into 5 into up to 50. Right. Now let's try to find out this way. Okay. So what we will ask, we will need the number from the user, right, of which factorial we find out. So printf, enter the number of which, or maybe to find factorial. So this is a message which we are giving user so that user will come to know what exactly he needs to do, right? So if he wants to enter the number, we need to use a scanf. When we use a scanf, it is just like this, correct? Now there are two things. It can be 0 or 1, correct? So you should basically just simply say if num is equal to 0 or num is equal to 1, fact is equal to what? 1, correct? Now what is a fact? We should basically have that as well then. We should have a fact to store the factorial. Now if num is not equal to 0 or not equal to 1, what we should basically do? Then we should basically find out fact is equal to fact star factorial of num. Now what did I do here? What I am saying, fact is equal to what? Fact star factorial of num. So I am trying to call a function here which will basically assign the value to fact. Then here we'll say, we'll print the value printf factorial of %d, or rather we should maybe try to put it like in a proper format. Yeah, so %d factorial is equal to %d. The first %d is for the num and another %d is what? For fact. Now, but this function is not defined. So what does this function do? This function will take integer and this function will also return integer, correct? So maybe let's try to first declare this function. So the declaration should be what? Factor is a function which returns integer and it also takes integer. So this is what we declaration is, right? This is the main function which is mandatory function. Okay, Now let's try to define it. Let's try to define it. So let's say x so maybe what you will try, right? You will basically try to start from the 5, right? 5, then 4. So, but where you need to stop? You need to stop at 1. So you should basically have it here. If x is equal to 1, what you should return? Return 1. So when x is equal to, so when the value of this is equal to 1, we will return. Otherwise, what we should basically do? We should just say return x into factorial of x minus 1. Now see what I'm doing here. This is interesting. The factorial is calling factorial, that's why it is recursion. We are stopping the value at 1, that's why I'm saying when it is x is equal to 1, stop all that recursion. If it is x is not equal to 1, let's add 5, x is equal to 5, so it will come here, it is not 5, so it will come on this line. It will say 5 into factorial of what? 4, so it will go again here. Okay, so in a stack, right, in a stack, this is how it is, correct? So it will be what? 5, basically 5 multiplied by, and then the function it has called factorial of 4, correct? So that's what it is, factorial of 4. Now, so from main it came to this, correct? So this will be from main. Now when it goes to factorial 4, it will check whether it is 4, no. So it will return 4 into factorial of 3. So 4 into factorial of 3, correct? So this is what? 3. So this is 8 to be done, executed, correct? Then similarly, it will go, factorial 3 will come here. Is it 3? No. So 3 into factorial of 2, correct? So 3 into factorial of 2. So 3 into factorial of 2. So factorial of 2. Now again it will come here with 2 value. Is it 1? No. So it will call 2 into factor of 1. So 2 into factor of 1. I'm not using the complete name because of maybe the writing part is slow, right? So factor of 1, but f means factorial. Now when this function is called with value 1, so x is now 1. Now it will come into this, x is equal to 1. So it will return 1. So it will return 1, and in this value it will be 1. So 2 into 1 is 2. So it will return 2, and it will come here. 2 into 3 is 6. 6 will come at the place of f of 3. 6 into 4 is 24. 24 will come at the place of f of 4. 24 into 5 is what? 120. 120 will come on the actual here, 120. And 120 into 1, that will be 120. So that's how the factorial works. Now let's see whether it is giving us the correct answer, right? So it is asking find the factorial of 5. Is it 120? Correct. So if I say a factorial of 8, correct? It is. If I say factorial of 0, I know the factorial of 0 is what? 1. Yeah. So that's all. Actually I had it from this video. we almost covered everything. What are the functions, how to declare the functions, how to define the function, right? How to invoke it, what does it mean by pass by value, what does it mean by pass by reference, pass by address, how recursion works in C. Okay, in our next video we will be covering structures and unions in more detail. There are three, four more topics are pending, like dynamic memory allocation, file operations, preprocessors, which we'll be covering in upcoming sessions. That will basically conclude the complete C language course. So once the programming course ends, we will start with the two more courses in the programming world, and those are Python and data structures with C. So current series of videos are like what we have covered until now is the functions. Okay, so thank you for watching the video. Please do not forget to like, subscribe and share with others as well. I wish you happy learning with the GravityTech. Thank you.